So like yesterday we got into inverses a little bit. And sorry, go ahead.
I actually did have a question.
Go for it.
So, how should we, basically know, how much we can explain our answers for each question without we have to answer any given question, especially on, 2.1, where a lot of them are kind of,
If you, so you're asking how do you know how much work to show?
Yeah, basically.
All right, I can't possibly answer that question for every possible circumstance. So in one sense, it's a little bit of, you have to kind of feel it out, but you almost never can just say the answer and then move on. You have to show me where things are coming from, yes?
Sure.
What idea did you apply? What did you simplify, right? You gotta show me something, yes? Now, if the problem was simplify -4 squared and you write 16, tears, right? You don't need to show work for that. You see what I mean? So the weird thing is, part of what I'm testing is, do you know when to do that? When you have to show work? And if it's something you can't just do in your head, you have to show work. Even if you could do it in your head, I still need to get something down. What did you do? Yes? There's no clean-cut way to write that. Anything I say is not going to be applicable in certain problems. So if I'm like, give me 3 lines of work, well, some is more, some is less. So there's no great way to answer that, which, from your perspective, it sucks, and I'm sorry. But any step that requires application of some process, you have to show me that. Or at the very least, you could explain, I did this and then I did this. In which case you're writing a lot, but maybe. If you have specific things where I said show more work or something, then we can talk about those specific situations.
Okay.
But general situations, there's no real good way to answer that question.
Yeah, so, maybe if we're looking at a graph, and we could see if it's a function or not.
Oh, if I say, is this a function, and you just say vertical line test, and you don't show me a graph, what?
Okay, so you would want
Did
to
it pass? How do you know it passed?
kind of sketch it? Maybe?
Yeah, so there was one, were you the one that at one point you said circle?
Yes.
Okay, see, that's beautiful. If you did graph it, it would be a circle and a vertical line would go more than once. I'm cool with that.
Okay.
You with me?
Yeah.
So you could give me a rough little sketch of what it would look like if you graphed it. And then you could say, this would pass a vertical line, or this would not pass a vertical line. Do you see what I mean? Just saying VLT, how do you know? What are you doing to figure that out? I don't see anything. Okay. Pretty okay. Let me ask you a question from the homework. I forgot to bring paper. Let me see. Here we go. I got some. Do I? Yes, I do. Yay. What is this? Oh. If I have this equation, why do I not even need to graph it? I'm trying to speak slow so this thing can catch up. If I have this, come to me. Google it. Okay. Can anyone tell me, does this represent a function or not? Tell me, somebody remind me, what does it take to be a function? Every input can have only one output, yes? What part of this automatically tells you if it's a function or not? What does y equal always? Read it. Plus or minus, okay, automatically most x's are going to give me how many answers? Let me make this a plus just to make this a little easier. This doesn't change anything about, okay, just make it a plus right now. Can you guys put a 3 in there? What do you get if you put a 3 in there? You get 4 inside, keep going. Tell me exactly what answer you get. No? Plus or minus 2, right? The square root of 4 is 2, but what's in front of it? What does this say is in front of everything? Alright. So almost always. I say almost always because what do I get if I put a negative 1 in? Plus or minus 0 is? What's plus or minus 0? 0. So you get one answer if you put a negative 1 in. Anything else that results in a real number, you get 2 answers, yes? If I plug a 1 in, what do I get? Plus or minus square root of 2. I get positive root 2, negative root 2, yes? So is this a function? Is there at least one input that results in more than one output? Is there an x I put in and get more than one y out? Hell yes. In fact, almost every number that I'm allowed to put in gives me 2 outputs. Do you guys see that? Do you guys see that? So, graphically, vertical line test is an application of the idea. Stay with me now, guys. Somebody with me? Okay, everybody's looking at something else. I'll be alright. You guys are with me. Alright. Graphical interpretation of the function is if I draw a vertical line, it goes through more than once. That is an application of the idea. The idea is, are there any inputs that give me more than one output? If so, it ain't a function. Do I need a graph for that? No. I can see right there. There are inputs that give me more than one output. I don't need a graph for that. I can just see it. Do you guys see that? I need you to really get this. There's an idea that is easy to see in a graph, but the graph is not the idea. The vertical line test is not the idea. The vertical line test is an interpretation of the idea. The idea is, if I plug something in, could I get more than one thing out? That's the idea. So I don't need a graph for this shit. I can see I'm gonna get 2 answers for a lot of things I could plug in. You guys see that? Okay? Good, good. Part of that's my fault. We always hyper focus on vertical line tests because graphically it's really easy. But that is not the thing. That is one version of the thing. There's an idea below that. Okay, maybe you guys are with me. So there's a whole section in the homework that gives you a bunch of y equals x squared, blah, blah, blah. One way to interpret some of those is you can see immediately some of them are going to give you more than one answer. Then you know it's not a function. End of story. Yes?
In questions like those, how would you like us to explain, like how would that?
This one you would just say the plus or minus gives me more than one output.
Okay.
And that speaks directly to the definition of function, meaning you can only have one output for every input. Okay, I like it. Other problems have other ways to look at that. If it was y equals x squared, do you guys know what y equals x squared looks like as a graph? It's a parabola. If you don't know this, can you square something and get more than one answer? Can you imagine a number that when you square it, you get more than one answer?
Yeah.
Give me it. What's negative 2 squared?
4.
Did you get more than one answer?
Oh, no.
Okay. Is there any number that when you square it, you get more than one answer? No. Is everybody with me? Is everybody with me? So if you just say, if you didn't know that it was a parabola, if you know it's a parabola, you can do a real quick stretch and say it passes vertical line test. If you don't know it's a parabola, you can say, if I square a number, I only get one answer. You're speaking directly to the definition. Every input gives me only one output. Tears, beautiful, next. Yes? Maybe? Contention? What about, here's a tricky one. My input is still x. So Somebody give me a nice number for x. And I'll help you out a little bit. 9 is a nice number for x here. Why? Where does x come from in this equation? Squaring y, correct? So why is 9 a good number for x? Because I can figure out where it came from. Sort of. So when I input 9 for x, does anyone see how many outputs I get? What do I square to get 9? 3 or? Negative 3. Do you guys see that? If I plug a 9 in, how many outputs do I get? 2. Was there an input that has more than one output? We just did it. So is that a function? No. There you go. So in some cases, you can give me a direct example. Well, Jeff, if you plug a freaking 9 in, you get 2 freaking answers out. That's beautiful. You don't have to say freaking. You guys with me? But you're speaking directly to the idea. Is there an input that results in more than one output? If so, no good. If never, beautiful. Maybe? Maybe? Potential. So it's just easier if it's a graph. That doesn't mean I have to have a graph. Because I can just think about the idea directly. Okay. Anything else from homework stuff? This, by the way, real quick. This is why it's so important to have questions from homework. There's so many little things I might not think to say in the moment, but if somebody asks me a question, I'm like, oh, this could trip up, and then I can speak to them. But I'm laying down the basic ideas. Without questions about homework problems, I don't know what you're having trouble with, how to apply those ideas. Do you see what I mean? Less questions from homework actually means a less robust experience for everybody. So don't hold back. If you ask a question, you're making everybody's experience better. Is that, you guys with me? I know every day I say something about this. Get used to it. Because this is where I want you guys to say, I never understood this shit. Let me ask this guy. See what this guy, hey, math boy up there, how do you do this shit? This has always bugged me. And if I can't answer you, then you should go tell my dean to fire me. Because my job is to explain an idea so you understand it. It's crazy. Okay. Nick. Yes?
So, I remember you said to me, you were starting the semester about what you write on homework, you might write on correct or okay.
Yes.
Okay.
So if I say correct in your homework, that means you have half credit. You can make corrections and turn back in. When are homework corrections due? Day of the final exam. Everything else is due the day of the test. Homework corrections are due later. What's up, Jenny? What's
You
up,
want
Jenny?
rags?
What's up?
You want rags or no?
Oh,
They're in the middle. That's
these look clean actually.
fine. Okay, don't worry.
Thanks, Jenny.
Sure.
Sorry. Jenny's cool. She's one of our chairs. So one thing she's done is she makes sure all the rooms have these clean whiteboard racks. That's the most I've used the whiteboard, I think. Is somebody else wrote some stuff up there. I don't like using the whiteboard. I hate this whiteboard. I missed my chocolates actually. Okay, I'm sorry. Where was I? Shoot. I don't know. I was saying all kinds of weird stuff. Oh, the homework. Yeah. Ready with me? I want you working on new homework. That's your primary focus. Old homework, corrections, finishing them, whatever, that's your secondary focus. You have until the final for that. Okay, maybe. Final's cumulative anyway. So it's all study. Yes? So, all that crap said. Anything else from the homework stuff?
Yeah, you like half answered the question. So
I'm sorry.
So correct is half credit, and then anything else that you write?
Correct is half credit. If I say finish, that's also half credit. Redo is no credit. But in both situations, you can correct it or redo it and get full credit. If I just say no credit, that's bad. That means you obviously copied from somebody or something. You with me? That's the one situation where you can't do shit. Anything else I say, you can get points back. If I say okay, you don't have to make corrections, but you also might have made some mistakes, but nothing major. You should still see what mistakes you might have made. So everybody with me? Yes?
Is there any time frame on turning in corrections on the quiz?
Yes. Everything is due the day of the next test. Homework corrections are due the day of the final. It's the one thing that's not due the day of the test. Okay. Anything else won't work? Okay. So what I want to do, we barely started talking about inverses last time. Inverse functions. Somewhere here we go. This is, no, shoot. Here we go. Beautiful. Yes. All right, let's do this here. So in the lecture book, get to this page here. So the idea, in order to be a function, what do you have to do? What must be true? For every input, there can be only one output. So a parabola is a function, yes? Yeah. Every input has only one output. It passes the vertical line test. Fantastic. What do you have to do? I don't think I said this last time, but do you remember last time we were talking about, last time being yesterday, being able to be a detective and work backwards? So if I said I squared something and I got 4, do you know exactly what I squared? No, you don't. What could it have been? 2 or negative 2, yes? So you do not know exactly what I could have squared, yes? If I said somebody killed John, do you know exactly who did it? No, but you can start collecting potential people, yes? So there's no way to solve that case quick. You guys I need you with me on this. If I have a function that, let's see if they have a better example. No. A bunch of the same paper, I love it. No, okay. This one, we'll just work with this one. If I square and then add 1, if I erase this side, if I say my function only starts at 0 and goes up, if I get a 2, do I know where I came from? Yes. Earlier, if my output was 2, there were 2 places I could have come from, yes? You guys see that? If I do what's called restrict the domain, make it so that it can only use inputs 0 and up. If I can only use inputs 0 and up, I'm gonna erase this half. Is this now an easy murder case to solve? Yes. How do I get 5? 2. Whereas over here, how do I get 5? 2 or negative 2. Yes? That would need me to go out and talk to people. Do you know negative 2? Did you see him last week? What about 2? Do you know 2? Over here, I'm like, oh yeah, 2 did it. Go get him. Throw him a jail. Yes? This is what's called a one-to-one function. A one-to-one function, and here's why that name makes so much freaking sense. To be a function, every input has only one output. So like, y equals x squared. If I put a 2 in, what do I get out? Y equals x squared. Put a 2 in, I get a 4 out. Yes? But if I have a 4 out, what did I plug in? Could be 2 or negative 2. So it's not one-to-one. One thing doesn't go here and it goes back to this one thing. One-to-one means it has to work both ways. So here, if I plug a 1 in, I only get a 2 out. If I got a 2 out, I only could have put a 1 in. One-to-one, it goes both ways. I love that name one-to-one, even though I don't know if it makes sense to you yet. Every one input has one output. Every one output has one input. Both ways, one-to-one. So now your question should be, holy shit, Jeff, you said a lot about these things. What's so great about it? If I know a function is one-to-one, that means it must have an inverse function. And why are inverse functions important? What are inverse functions?
Undoing.
Yes, it's the function that undoes what the other function did. You guys remember yesterday? If I make 4 become 5, I can turn the point around and it brings 5 back to 4. It undoes what the other one did. For example, if I had I just had paper. Where did I put it? Oh yeah, it's right here. There. If I have the cube root of x, what can I do to that to kill the cube root? How can I undo the cube root? Somebody else? What's the opposite of a cube root? You could do it. Yes, a third power. Yes? Doesn't a third power undo a cube root? So if I apply a third power to a cube root, don't they cancel each other? Let's try it. What's the cube root of 8? 2. What do I get if I cube it? 8. See how it made it go back to 8 again. I started with 8, I did shit, and I ended with 8. So the two functions evolved have to be opposites of each other, because whatever one did, the other one undid. So why are inverse functions so important? I can't solve shit unless I know them. What's the only reason we can solve x plus 1 is 7? Because we know the inverse function for addition. It's subtraction, right? If I didn't know the inverse function, I'm screwed. We're living in caves. Math people always go to that. If you didn't know math, you'd be living in a cave. Whatever. Okay. Are you guys at all with me? So an inverse function's job, sort of, and this one way to look at it, is to undo the function it came from. It undoes whatever the first function did. I love me. I hide stuff from myself. Oh, I didn't even take it out yet. Okay. So, real quick. Here's the beautiful thing. To be a function, graphically you have to pass the vertical line test. Holy shit, Jeff. Sure, that'll work. To be a one-to-one function, you also have to pass the horizontal line test. I'm pretty sure I ended up with that. I said that yesterday. Okay. What I do want to do, I want to go back. I want to do one more visual example. It's dumb. All right, I'm going to use, if you have your book or if you have the stuff I gave out yesterday, we're going to use this here, but screw this. We're going to do, screw this. We're going to do this here function here. X squared minus 4. No, Jeff. Sorry. X cubed minus 2. Sure. Okay. If I want to plot that x cubed minus 2, I can make points, yes? How do I plot this function? Like, what do I get if I plug in a 2? Yeah, 2 cubed is 8, minus 2 is 6. What do I get if I plug in a 1? Say again, sorry?
Negative 1?
Yes, 1 cubed is 1, minus 2 is negative 1. What do I get if I plug in a 0? Yeah, 0 minus 2 is negative 2. That's crazy. What about negative 1? Yeah, negative 1 cubed is negative 1. Minus 2, what's negative 1 minus 2? Negative 3. Okay, good. So I've got 2, 6, 1, negative 1, 0, negative 2, and negative 1, negative 3. So a cubic looks like a parabola where half of it fell out. Shit in half. There you go. Is this 1 to 1? Why? Passes the holt. Yes. So let me show you another reason why the horizontal line test makes nothing but sense. What does a vertical line test do? Anything I give you visually, what would a vertical line test for? If it passes it, what does it mean? Vertical line test. Vertical line test. If it passes it, what kind of thing am I looking at? If I give you a graph,
If it goes through like one.
just give me one word, starts with an F that you can say in mixed company. Function. If it passes the vertical line test, it's a function, yes? You with me? So are you with me? So that we know. How do I graphically get the inverse for this? We did this already. We got the graph. We know it's got an inverse because it's 1 to 1. No. We don't have to do any math. Yes. What does the inverse do? It takes the output and brings it back to the input. So the output becomes the input becomes the output. Just switch the frickin' X's and Y's. That's almost too easy to believe. So if I give you a graph and I say graph the inverse on top of this, just find all the points and turn them around. So 6, 2, -1, 1, -2, 0, and -3, -1. So now this looks like this. Wow. Why does that look right? Does anyone remember where the mirror should end up? Well, first off, where does it look like there's a mirror here? Can you kind of do it in the air? How's the mirror situated? Yes, at an angle, yes. In fact, it's a 45-degree angle. There's a mirror right here. Now, what's neat about math functions, they're able to go into the mirror, which is neat. But we're cool with that, right? So there's a reflection around this line, I should say it like that. And that line is the y = x line. It makes sense that there should be a reflection around the y = x line, because how do we make this picture? We switch the y and the x. So it should kind of hop over the y = x line. Okay, let me stop for a minute. Does my inverse graph pass the vertical line test? So that means my inverse is a function. So I need you to see. I really want you to be with me on this. Didn't we take the original function and we flipped it? And then we applied a vertical line test. If I don't have to do any of this shit, if it just says, hey, you, is this 1 to 1? Instead of flipping the function and doing a vertical line test, we leave the function alone and we do a horizontal line test. We flip the test. I need this to make sense. If I flip this and I do a vertical line test, couldn't I have left it alone and done a horizontal line test? It would have been exactly the same results. That's why horizontal line test makes sense that it exists. It's like, instead of graphing the damn thing, flipping it, and then doing vertical, no, just do a horizontal line test. Just get done with it. Okay, baby. Love you guys. Vertical line test tells you if it's a function. If it also passes the horizontal line test, it's an invertible function. Okay. Now, obviously, in mathematics, not everything is graphs. Where's a good example? Should I just make my own up? Yes, I'm gonna make my own. So what if I had this? Cube roots, we basically just did, well, I don't know if you guys are understanding, but didn't we just do a cubic? Was the original one a cubic that we just did? Where'd you put that, Jeff? Here it is. The original one was a cubic, yes?
Yeah.
So what do you guys think this fundamentally is? What's the inverse of a cube? Don't even, what's the inverse of a cube? What's the opposite of cubing something?
Let's keep it.
Cube rooting something. So this is the graph of a cube root. Because a cube and a cube root are inverses of each other. So a cube root has an inverse. So this problem would say, these functions have inverses, find their inverses. So I don't want any graphs. I want to know what the function definition is of the inverse. Like, what's the inverse of x plus 3? X minus 3. Yes? And you're like, give me that problem, Jeff. No. So, real quick, stay with me. This is almost too good to believe. Stay with me. Okay. So you guys are nodding off. I'm sorry. You can turn my YouTube on and listen to it. Go to sleep later. How do I graphically find the inverse? What did we do? We had a list of x's and y's, and we just changed the x's and the y's. Yes. You with me? This is too nice. Do the same shit. We do exactly the same shit algebraically. What do I mean by that? Switch the x and y. What's it look like if I switch the x and y? Switch the x and y. What do you get? Switch them. Just switch them. What do you get? Switch them. X equals cube root y. Now solve for y. Now real quick, listen. What does that original function do? What's the last thing that the original function do? Do you guys agree it subtracts 3? Can you guys guess what the inverse function should do somewhere? It better add 3 somewhere. Yes? This original function cube roots my input. What better happen at some point in my inverse function? It better do the opposite of that, which is cubing. Now, don't guess what the inverse. This is too nice to believe. If I start to solve this for y, what's my first step? Add 3. You always find where your variable is and get that thing by itself. So I want to get rid of this. Add 3. Didn't we just say? So I need you to see, this is almost dumb. How do I find the function that is all the opposite shit? If I switch x and y and solve, I'm going to do all the opposite shit. Because what does solving involve? Undoing shit. Yes? So if I add 3, and now what do I do? What's the last step here? How do I kill a cube root? Cube it. Yes? These die, so y is x plus 3 cubed. Please, dear God, don't actually FOIL that shit out. Yes? You can stop right there. Does that add 3 like we thought it should?
Yes.
Does that cube like we knew it should?
Yes.
Yes, it's just the order it does it in that I didn't know until I did this process. So if I give you a function written out like y equals blah, 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 say find the inverse, you just literally switch the x and y, and then solve for y. It's almost too good to believe. It's really too good to believe because it's exactly the same shit we do graphically. So you don't have to memorize as much shit. How do I find the inverse? Switch x and y no matter what. Graphically, algebraically. Okay. So here, you guys try this one. Try to find the inverse function. Joey? 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 Hope Joey's okay. Okay. Where did I put you? Nope. I think here they are. Let me catch up to you guys. Is anybody freaked out about the fifth root? We shouldn't be freaked out about it, of course, right? What's the opposite of a fifth root? Fifth power, yeah. What's the opposite of cutting things in 5 pieces? They can have 5 times as many, fifth power, yeah. So what's the first step here? Very first step. Switch the X and Y. The reason I do this little dotted line, I can't stop myself from doing it. Other instructors might not do it. That tells me from this step to this step, I just did something. I didn't do something algebraic. I applied an idea. When I'm solving an equation or I'm simplifying, every step should be an algebraic manipulation. There's no way in hell I can just make these go here algebraically. I'm applying an idea. Is this little dotted line important? No. But I'm going to do it for myself all the damn time. I can't stop myself. I'm sorry. What's the first step now to try to solve for y? Take away home? Take away 4? And then what? Yeah. Raise it to the 5th power so these kill each other. And then what?
Subtract it or add.
Add 2 to both sides and end up with y equals x minus 4 to the 5th plus 2. Please understand you can stop there. Do not write that 5 times and multiply. Oh my God. Especially not in the test. You only have so much time. Don't do that to yourselves. Oh, did I lose? What did I put a 5 there for? Yeah. I love. It's so fun getting old, everybody. Okay. Although I would have done that same thing when I was 20, so who cares? What did the original function add for? At some point. Did the new function subtract for? Did the original function subtract it? Did the new function add to? You can kind of see how it, not only does it all do all the opposite operations, it does them all in the opposite order. What's the last thing this guy did? Add 4. What's the first thing this guy does to an input? Subtracts 4. So it does all the opposite shit in the opposite order. So let me show you the correct way to identify this. You ready? I'm sorry, go ahead.
So, what exactly are we doing again on the very last line where we're crossing something out, basically?
Here?
Yes.
Oh, the 5th root and the 5th power are opposite operations, so they cancel each other. Just like subtracting 4 cancels these out. Yes? Because subtraction is the inverse of adding. Is that your question?
Yes.
Yeah. So if I had a 7th root, I would apply a 7th power and so on. Yeah. Okay, I like it. Hey, Mikey. So, just to show you, if they had given us written in function form, the answer we just got, this one, would be what the inverse function is. So given f with a -1 up here, I read this as f inverse. What really sucks about this choice we made is what do I do when I raise something to a -1 power? I just flip it, yes? That is not what that means. That means the function that does the opposite. In fact, is this the reciprocal of this? Is this just this flipped? No way. It's not 1 over this shit, is it? So that is really poor choice of symbols. But again, a lot of us math people, we were high on something. So we didn't make a good choice here. So you have to be really diligent about realizing this means the function that does all the opposite shit. So real quick, here, not real quick, but sort of quick. Yeah, let's do the one here. Does everybody still have this handout? I have a couple more in case you need one, but does everybody still have this handout? Let me know if you don't. We left these two undone, obviously, because we hadn't talked about them yet, so it makes sense.
I don't know.
You want? How's everybody else? Everybody else is good? Yeah. Okay. Can you guys take a moment and figure out what F inverse is? Here's the F function, right? Try to calculate F inverse. So you got your F function up here. Figure out what F inverse is. Oh yeah. Before I forget, you guys remember what's happening tomorrow? Quiz. Does anybody remember what it's on? 3, 1 through 2. Beautiful. I love it. Yes. This one's not too bad, right? The function, so what I always do, I bring y back real quick. I bring y back. Yes? So if you were confused, if you didn't know you could do that, what did f of x take the place of? Y. So bring y back. And now what do I do to start solving for the inverse? What do I do? What did I do? What did I do? What did I do? Yeah, swap x and y. And now solving for y is not too bad. There's nothing too crazy going on here. How do I solve for y?
Add one to both sides.
Add 1 to both sides. And then
Divide both sides by 2.
divide by 2. So I get y equals this, which means f inverse is this. The original function subtracts 1, this one adds 1, the original function multiplied by 2, this divided by 2. Okay, everything looks good. I want to go one step further with the example we just did. So already got all that business? Look, guys, please let this be not too evil. This really isn't that evil. And I should know, I know evil. So the function is 2x minus 1. The inverse is x plus 1 over 2. What is the inverse's job again? What's the one way you can look at it? What's the inverse supposed to do? It's supposed to undo whatever f did. If I take f inverse, let's say it this way. If I take the function and I shove it into f inverse, what should happen? What's the input for f? No. What's the input? X. And so what's this function do to my input? It doubles it and takes 1 away, yes? That function's job is to undo that, yes? Can anyone guess what I should get out if I take this function and shove it in there? Okay, let's see. Let's see what we get. I'm going to take this function and I'm going to shove it into f inverse. So I'm going to take this, I'm going to shove it in. So what's that mean? I'm going to take this, I'm going to shove it in. Is that cool? You guys all right? Okay. I'm sorry I'm using very technical language. Shove it in. Here we go. I'm going to replace x with 2x minus 1. Somebody help me out. How do I do this? So all I did was I put 2x minus 1 right there. The 1's cancel, yes?
Yeah.
And then what happens? The 2's cancel, and I'm left with, there we go, because what did I start with? I fed x to f, and it did shit. So if I plug that into the inverse, it should undo the shit. It should end up with x again. It should get me back to where I started. Do you guys see that? If I plug an x into f and it does this, the inverse better undo that, bring me back to x. Does it? Yes. So if you have a problem in the homework, or in a test or a quiz, that says, here's f, here's what I think f inverse is, verify. You just take one and plug it in the other one, see if you get x. See if they undo each other. Yes? Okay. Can you guys go ahead and figure out what G inverse is? It's going to be a little more complicated. Try to figure out what G inverse is. Christina and I can roam. If you guys have questions, go ahead, give it a try. In case you don't have the sheet, because you don't want to tell me for some reason, here's G again. You guys should all have the sheet. It looks like you're plugging G into F. This question has nothing to do with F. So you take G.
Yeah.
I would replace that with Y and bring Y back. Y equals this, and then you switch X and Y. Yeah. You don't have to bring F into it at all. So we get Y equals this, and then I just replaced Y with F inverse. So we started with F, and it become Y. Switched X, Y, solve for Y, and now that's the inverse function. So F of X equals this, F inverse equals X plus Y over 2. Yeah, so we get Y equals this, and we replace that Y with F inverse. Now that's the opposite function. right, let's take a look here. Yeah, okay. So I'm gonna write this, I'm gonna replace G with Y right off the bat. Let me give myself some more room. Then I switch the X and Y. And then I start to solve for Y, right? Whenever you're trying to solve anything in the universe for a variable, you find what term has the variable in it, and you get that term by itself. So the first thing I want to do is get rid of that 1. Now how do I get rid of that cube root? That's insane. Now you gotta be real careful here. If I take away 1, I get x minus 1 cubed minus 1. So first off, don't make that a freaking negative 2. You can't have that break in there somehow. Secondly, what's left on this side? Negative y, good. I always get somebody to forget that negative. So what's the last thing I have to do? Divide by negative 1. So I get 1 minus x minus 1 cubed. The negative 1 becomes positive, the x minus 1 cubed becomes negative. Equals y, and I can replace y. What symbol can I put here in place of y? You can do it. I told you up here. Didn't we just find the inverse function for g? So that's g inverse. So I'm not going to make you do this, but if you took g and shoved the whole thing in there, it would come out to just the x. Yeah, maybe. Let me do this on a smaller scale. Did we do... Yeah, right here. Do you remember g of 2 was 0 up here? G of 2 is 0. Can somebody tell me if g of 2 is 0, what does g inverse of 0 have to be?
0.
No. Don't say it like that. If g of 2 is 0, what's g inverse of 0? 2. I like that. I thought you were giving me a peace sign. Like, dude, I mean no harm. Okay. No, you're saying 2. I love it. Do you guys see that? Do you guys see that? So let's test it. Do we have g inverse? Yep. What do you get when you plug a 0 in? What's 0 minus 1? What's negative 1 cubed? Negative 1. And what's 1 minus negative 1? 1 plus 1? 2. Just like we said, we should get 2 out, yes? The inverse function must take the output of the original and bring it back to what it was. It undoes whatever it did. If I have a function that doubles the length of something, the inverse better cut the length back in half so it goes back to the original size. Okay, maybe? Okay. I love you guys. Cheers. Okay. And I don't think, we didn't do this did we do this last time? I did an example like this, but I didn't do this one. Do you guys remember how to do this? Do it real quick. Do it. Do it. Everybody, hey everybody, do this one.
You're graphing the inverse?
Yep. So given that function, well first off, why does an inverse exist? Can anyone tell me? What test do we use?
Horizontal.
Does it pass the horizontal line test? What does it mean to pass the horizontal line test? Any horizontal line goes through at most once. And sure enough, if there's no horizontal line that goes through more than once, go ahead and graph the inverse. I'll just state it here. It'd be really useful. This is what I always do for myself. I collect all the points I see for sure. And then what do I do? Flip. Because that one's a nice one. That's the real MVP. So -7, -10, 0, -5, 5, 5. That's where it touches the mirror. 10, 7. There's my bug. Look at my bug. Okay. And you can see the y = x line is the mirror again. It's really nifty if you let it be. Let it be. Let it be. Okay. Did anyone look at NASA lines? It's okay if you didn't. My man right here is about to do it. We're doing it live. I can look them up too. NAZCAS. This is like a hyper simplified version of a NASA lines, but they're still really cool. That's what I always thought of when I first learned this. I'm like, wait, this is really good NASA lines. Okay. All right. Oh, and then number 3, I sort of boxed them in here, but can anyone do that? Like, did I even tell you what H is?
No.
I didn't give you what the H function, did I? God, I'm an asshole. Can you still do that? Can you guys see what happens? What does the H and the H inverse do to each other?
The H is redoing. So
Huh?
it's just gonna be A.
It's just A. But an H and H inverse, they kill each other. If I cube a cube root, they kill each other, and I'm left with what's inside. So whatever H is, I'm saying H inverse exists. And so if I interact one with the other one, they're gonna cancel each other. So the answer is A. It's just like cubing a cube root. Adding 7 when something else subtracts 7. I get right back to where I started. These kill each other. The answer is A. That's too nice to believe. Quick question. If I told you f of 7 is -4, what's f inverse of -4?
7.
Right? Because that's the basic idea of inverse functions. They switch the x and y. Don't let that problem be a problem. Did I tell you what f was? I didn't have to. I just told you exactly what you needed to know. Shabam. Kick ass. Okay. So, sorry, by the way, if you haven't picked up on it, today's a lecture heavy day. Very sorry. Tomorrow, first thing, we're going to do a really nifty, I don't know how you guys feel when I say this. It's going to be a nifty group work exercise. And you're all like, shit, what does that mean? He thinks it's nifty. It's got to be crazy. No, it's nothing too crazy. Okay. So, I'm going to get into, that's chapter 3 for the moment. I think we'll come back to parts of it later. What I want to focus on for the rest of the time is linear functions, lines, right? We're going to do lines the legal way. Can anyone tell me anything you remember about lines? Mathematical idea of lines. Does anyone remember anything? Y = mx + b, that's huge. Does that sound at all familiar to anybody? Y = mx + b. Did that rule part of your life? Yeah, there we go, now we're talking. Okay. By the way, if you forgot any of what we're talking about right now, we're going to go over it, but I just want to see what everybody remembers. I think most of you guys remember this, if you haven't blocked it out of your memory. What did the M represent? Slope. A really, really good question would be, why? Why does M mean slope? In fact, real quick, we're not exactly sure, but isn't it kind of dumb? What kind of math genius We go, what letter do we use for slope? Let's use a letter not in that word at all. Let's use M. So the theory is, there's a French word marche, which means to walk. And a slope is sort of like telling you how to walk, to stay on a path. So they think that maybe that's where it came from? We have no freaking
They
clue.
don't know.
It's from the geniuses that brought us f to the negative 1, so who knows? Okay, maybe. Maybe? So this is the slope. Does everybody sort of vaguely at least remember that? You might not remember why this is the slope, but does everybody remember that's the slope? What was this other dude? The y-intercept. So I'm going to start with, I'm not going to start with any of this. This is a little too far along the road, but I just want to see what everybody remembers. Does anyone remember anything else? Like, for a straight line, can the slope change? If the slope changed, what would happen? My line would curve, yes? So if I have a straight line, it's got to stay the same slope. So if the slope is 5 over here, it's 5 over there, it's 5 freaking everywhere. That's the part of the definition of that line. Are you guys with me? When you get to calculus, you're going to have shit that's changing the slope all the damn time. It's going to be very exciting. Does anyone remember how to get the slope of a line given 2 points that it goes through?
Rise over.
Kick-ass. So if I give it to you graphically, oh man. Oh my God. Jelly goes, oh my God. Jeff. I can't. Okay. There we go. So everybody get this copied down real quick. So if I had one point is here and the other point is there on this line. Ooh, that's the straightest line I ever drew in my life. What's the idea of slope? Somebody just said it. Rise over run. Does that sound familiar? When I rise, which variable is changing? The y. In fact, what's really beautiful about rise is it rhymes with y's. So rise is the y's, run is the other one. Still rhymes. So rise is y's, run is x's. Yes, you guys with me? In fact, what is slope in the real world? What is the slope in the real world? Has anyone ever gone hiking?
Yeah.
And why do they have all these switchbacks? Like you do this and you do this? Because if you went straight, you'd be like, you know, or you go mountain climbing and then you're talking about a stupid slope, yes? Has anyone ever been driving somewhere and you saw the grade of the road? And it said something like 7% grade. Has anyone ever seen a sign like this? So real quick, what the hell would 7% grade mean? Is somebody watching you and you're going to get a grade at the end of your life and say, this is how well you drove. I can't believe you didn't kill anybody. You got a 0 on that one. No, alright, you guys with me? What the shit does 7% grade mean? What's 7%? I know we haven't talked about this in this class, but what is 7% as a fraction? Do you guys remember what percent means? 7 over 100. Rise over run. Every 100 feet, I rise 7 feet. Or if I'm going down the road, every 100 feet, I go down 7 feet. Are you guys with me? I'm demystifying this. So a 12% grade, if you don't know this, is huge. The 12% grade is when you have these runaway truck ramps. I'll never forget the first time I was driving through Colorado. First time I ever saw a runaway truck, I'm like, whoa, and I looked over, I'm like, runaway truck, holy shit. So I'm like, looking behind me, runaway trucks. I'm like, that's not good. Have any of you guys ever seen a runaway truck ramp?
No.
Alright, going down the steep grade, there's a pull-off where there's a lot of sand and it kind of goes up. If the truck's brakes fail, the trucker can pull off the road, go up in the sand, and it will slow them down. Are you with me? So I saw that shit, and I'm like, watching my rear view mirror, like, I don't want a truck to come slamming into me. Okay, maybe. You guys semi with me. 7% is 7 over 100. 7% grade going up, every 100 feet is 7 feet up. That doesn't sound like much, but when you're going 50, 60 miles an hour, that's pretty good. You with me? 12% is insane. 12%. If you drive, what's that street? Down through Golden Hill, and then you go down. There's like this crazy down. I forget what. I don't know if you guys ever went that way. There's it. I was dating somebody with little kids, and I would love to go that way home, even though it's a long way home, because I would just stop and go, "Everybody ready?" Because it's just this crazy slope down this thing. Okay, I'll stop. So if I look at this, pick either point. Somebody, I'm going to call this point 1, I'm going to call this point 2. Somebody pick a point. Which point? Point 1, okay. How do I get from point 1 to point 2? How much do I go up? How much do I rise? 1, 2, 3, yes? So far the slope is 3. And then how much do I run? 1, 2, 3. How much do I run? 1, 2, 3, 4. So that slope on that line is 3/4. Just double checking. So, you guys with me? That's a 3/4 slope. So that would be like 75% grade, which if that was on a road, no, it's not on a road. No, it's not on a road. Because your car would probably start to pull back off of the road. Okay, all right, this is my life now. Okay. You guys all right with me? Here's why I said either point. What if we pick the other point? How do I get from this point to that point? Do I rise? I fall. Isn't falling the opposite of rising? Ooh, we're breaking new ground here, guys. So if I go down, that's negative. So I'm going to go down 1, 2, 3. Good Lord, Jeff. Your point's really weird. Okay. I go down 1, 2, 3. And then I go back how much? So I go down 3, back how much? Back 4, so -4. And that still comes out to be 3/4. So either way you look at it, the slope will always be the same. Now, I think I asked you guys this yesterday. What formula does this relate to? This is an idea. If I have a graph, I can do the idea. I'm not really doing any computation, really. I'm just counting, yes? Do you guys know what formula this relates to? Why is this 3? Because what's the second y? What's the output here? 2. And what's the output here? -1, yes? So if it starts at -1 and it goes to 2, how much did it actually go up? What's 2 minus -1? What's 2 minus -1? What's the distance between 2 and -1? 2 minus -1 is 2 plus 1 is 3. There you go. So the difference in the y's divided by the difference in the x's. What's this x? 1. And what's this x? -3. What's 1 minus -3? 1 plus 3, 4. Yeah, blah, blah, blah. So that's y2 minus y1 over x2 minus x1. So graphically, I don't need y2 minus y1 bullshit. I could just count. But if I don't have a graph, I don't want to waste time graphing, I can just use the formula. It does exactly what steps do. So the formula for slope is y2 minus y1 over x2 minus x1. If I have a graph, I don't need the formula. That's the magic thing about math. Math is a bunch of formulas. Do you always need the formulas? No. Math people sometimes make it feel like you do, but you don't. Okay, stop for a minute. Are you guys remembering this stuff? Yes? All right. So now let's do this. Let's do a few things. Yeah, I think I want to do it this way. let's say I have this line here, yes? Before I make you tell me anything about it, let me ask you a couple questions. Who gets to pick what numbers to plug in? Well, X is where I plug stuff in. Who gets to pick what to put in there? If I just tell you, plot points and then graph this, how do you make the points? How do you make points? Pick them. How do you pick them? What do you mean? So I'm going to pick the 0.17. Is that good? Why is that bad?
That's an annoying number.
No. Why can't I use the 0.1, 7? What has to be true? What makes sure that it is on that line? I pick a value for what? X. And then Y can't be whatever I want it to be, right? That's the trick. That's why when we graph these things, all the points have to work on that. And that's why the graph actually tells me something about this thing. So, we can choose whatever we want to plug in here. We're probably not going to plug in there 1248 because I don't want to go to 1248 on the x-axis. What's a good number to plug in? Give me one good number to plug in. And I will help you. 3 is a bad number. 1 is a bad number for this specific problem. Do you guys see why? Can anyone tell me a good number to plug in? 2 is a kick-ass number. Do you guys see why? Somebody's going to be like, no, man. How about instead of asking me, you tell them, I'm sorry.
6.
What's the first damn thing I do to a number that I plug in? Don't I divide it by 2? And then I can multiply by 3? So then what kind of number do I want to plug in? Frickin' even. Yes? Or 0. Yes? So when I ask you to graph things, you can pick your points. Be smart about it. Don't put 3 in there. I don't want to graph that shit. I want to graph a nice whole number, and you're the humans, I think. I don't know. I'm going to assume you are. And you must assume I am. We get to pick. So let's see. What happens when I put a 2 in? What's 3 halves times 2 plus 1? What happens here? What happens here? These guys cancel. Yes, that's why we picked it. And what's 3 plus 1? 4. Or 6 over 2 is 3 plus 1 is 4, either way. Yeah. What if I put a 0 in there? That kicks so much ass. What do I get? 1. What if I put a negative 2 in there? The 2's cancel, the negative's still here, right? What's negative 3 plus 1? Negative 2. I like it. Let me stop right there. All we did was we chose numbers, we plugged them in, and we saw what we got out. We're making points, yes? Stay with me. Before we plot these, I want you to notice, how much did my input change from here to here? Didn't it go up by 2? How much did my output change from here to here? 3. It went up by 3. How much did my input change from here to here? 2. Went up by 2. Here to here? Went up by 3. What's the slope from the beginning?
3.
Rise 3 for every run of 2. When I run 2, I rise 3. You can see the damn thing happening with the numbers, yes? So why is 3 halves the slope? Because whatever I make x, if I change x, my y changes by 3 halves times that. That 3 halves is like I call it an amplifier. Even though it could be like 1/2, which it would mean it, but whatever x changes by, that tells me how much y is going to change by. So for every 2 I change the x by, the y is going to change by 3. That's why the slope is 3 over 2. That's why whatever number is there is the slope. What's the y-intercept?
1.
And in general, what's the y-intercept? What's like a definition of y-intercept? What does that mean, y-intercept?
Where the line crosses the line.
It's where the line crosses. 'Crosses. 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 ' disconnected from this problem. If I just draw a bunch of lines, wee, ha, hoo, can you guys see a bunch of y-intercepts? What is true at every y-intercept? What's true? They're all different outputs, correct? But what is the input? Always 0. So when I plug a 0 in, the output's going to be where it is on the y-axis because I haven't moved left to right yet. So of course the stupid number by itself is the y-intercept because when I plug a 0 in, this whole thing dies. So if I look back at mx+b, students cringe because there's no numbers here, but make x 0, what do you get?
B.
Freaking b, so of course that's the y-intercept. Maybe. So, don't worry. So if I want to graph this, I literally just graph the points. Literally. So I got 2, 4. You can do it, Jeff. There you go, buddy. 2, 4, 0, 1, and -2, -2. Holy shit, what have you done? My scale sucks so bad, Jeff. This is why, real quick, guys, I actually have a pad of graph paper that I forgot to bring with me that I normally need because my scale normally sucks pretty bad if I try to draw it myself. I think that still sucks pretty bad. Let's see if this is, no, that sucks really bad. I'll be all right. 2, 4, 0, 1, -2, -2. Okay, that's a little better. I don't have to cheese it too much. Make that big. There we go. All right, there's my line. Okay. You can see the up 3/2 happening. Yes. Okay. Now, real quick. I know some guys are probably really good with line strikes. Some of us have not taken math in a while and forgot all this shit. All right. Yes. Do it again. Oh, you don't have the sheet? Wait.
No.
Oh, tissue. I'm sorry. I think there is. Oh, there is some left in there. Yes. Okay. Now, if there are y-intercepts, there has to be
X-intercept.
x-intercepts. Do you see this x-intercept here? Is it a nice number?
No.
How would I find it though? How do I find the y-intercept? I make x.
Plug in 0 for.
Yeah, to find the y-intercept and make x 0, how do I find the x-intercept? Make y 0. Very quickly, the last math course I took, I think it was math 696. Sit on that shit for a second. I had an equation with 12 variables in it. You with me? And I had to find the w-intercept. How did I do it? I made all the frickin' other letters 0. So I don't care how many frickin' dimensions you live in, we're living in 2. If I want to find the blank intercept, I make all the other variables 0. So how do I find the y-intercept? I make x 0. How do I find the x-intercept? I make y 0. What happens when you make y 0 here? How do I solve for x? Subtract 1. Does anyone know how to do that in one step? Kill the 3 halves? Multiply by 2/3, the reciprocal. Right? So if I multiply both sides by 2/3, what do I get? Over here, these die. I get -2/3. And if you look at my crappy graph, that's not too bad. It looks like it's a roughly 2/3, yeah? -2/3?
Yeah.
Thank you for that. You're like, yeah, you got close, Jeff. I'm gonna say yes.
It's better than I could do. So.
All right, I'll take that. You guys with me?
Yes.
So if I ever just say find the x and y intercept, you don't have to do anything else except plug a 0 in for x. Plug a 0. Now be really careful. Be really careful. I always got to remember this. What exactly is the x-intercept?
Where x.
No. I mean from our work. What is the x-intercept?
You get 2/3.
No.
Oh.
What did we make y? 0. So intercepts are points. They're points in the graph, correct? The y-intercept is the point where it hits the y-axis. The x-intercept is the point where it hits it. If I say what is the y-intercept and you give me a number, you're wrong. I'm not going to take a bunch of points off. You with me? If you said the x-intercept is negative 2/3, I might take a point off. The answer has to be a point. When y is 0, x is negative 2/3, they go together. That's why points have two parts. One leads to the other one. Is everybody with me? Kind of, sort of. So, can somebody just tell me directly, without doing any work, what is the y-intercept?
Negative
Mm. Do it again.
11. 0, negative.
There it is. Okay. You with me? So be really careful. B is the y value of the y-intercept. So what's the y-intercept? 0, negative 11. How do I get an output of negative 11? I would put a 0 in for x, correct? So 0 goes with negative 11. That's why the point has two parts. I have an input that goes with an output. Kick ass. Kick ass. What would the slope be? Which means what? Rise 4, run 7. So you ready? I wasn't planning on doing this, and that's why I made the numbers gross, but now I want to graph this. So my y-intercept, let's see, 2, 4, 6, 8, 10, 12. Okay, not too terrible. So my y-intercept, and let me do this. Okay. So this would be 2, 4, 6, 8, 10, 12. Negative, 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 negative. And now I'm going to do 1, 2, 3, 4, 5. Oh my God, Jeff. 2, 4, 6, 8. 1, 2, 3, 5. Okay. What do I know for sure that this graph goes through? 0, negative 11. So I'm going to graph 0, negative 11. And then how do I move from there? I go up 4. Jeff, 7. Damn you, Jeff. So up 4. 1, 2, 3, 4. And then right 7. Okay. And as you do these, you can make whatever sound effects you want. You guys with me? So if I give you the equation, you don't have to make an XY table at all unless I ask you to. If I just say plot this, get the slope, y-intercept, plot the y-intercept, and then move. The slope tells you how to move, the y-intercept tells you where to start. And maybe. So let me give you this. And as I give it to you, I'll see if I've done, where is it? Oh, there it is. Oh man, oh man, I'll be all right. Oh, there's one. Okay. Anytime. I can't remember if I showed this to you. So I just want to, let's see. All right, you guys could definitely do 1, 2, 3, 4. I love it. So do the first 4. I'm not going to force you into groups, but you can work together if you want to. Call us over if you need help. Alright guys, I'm gonna take a look at these. This first problem has got to be nice. Every now and again we might have a brain burp and freaking switch these around. So like -1, the first one tells me how far to go left and right, the second one tells me to go up and down. So -1, 3. If I assume a scale by 1, right? 0, 2, where would that be? Yeah, don't go left and right at all. I just go up 2. What about -3, -5? Tell me how to go from here. Left 3. Down 5. And what about -4, 0? Left 4 and up and down none. Wow. Okay. Not too bad. Not too shabby. So there's this tiny little thing about this crazy ass equation that I want students to really understand. The only reason we have little subscripts is because if I do -4 minus 5, I must do -2 minus -3. Oh, what is that? So I get -9 here, right? What if I did the other way? If I did the other way, I would do 5 minus -4 over -3 minus -2. I have to go the same way. That's the only reason we have the 2's and the 1's. Because now, even though I went the other way, I'm going to get 9 divided by -1, which is still -9. It's got to match, no matter which way I go. Okay, maybe. Maybe? Maybe. What's weird about part B?
It's not a function.
Yeah, your slope is going to be -5 minus 1 over 6 minus 6. So you get -6 over 0. The shit's that? Remember this. -6 divided by 0 is the number that when I multiply by 0, I get -6. Is there any number that does that? No, there's no number that does that. What kind of slope is this? Do you guys know? Good. It could be undefined. Did anybody ever call this infinite slope? No? Okay. If all I do is go up, that's what this says. What's the only thing this thing does? Does the x change at all?
No.
It just goes up. So if it just goes straight up, that's infinite slope. It just instantly goes from here to there. It's at infinity now, right? It doesn't gently, slowly get there. It just goes there. Wow, shit. You with me? So I don't want a ramp. I want to go like that. I don't want to have to get to the building going straight up. I'm on my way. No good. Okay. That's why we don't have a lot of climbing walls to get into buildings. So you can call this undefined. You can call it infinite. Oh, Jeff, you keep choosing poor. Are both of you dead? Infinite. But it sounds like most of you guys are used to calling it undefined. That's fine. So you can't divide by 0, kids. Bad things. What about over here? How do I find the x-intercept? How do I find the x-intercept? How do I always find the x-intercept? Make y 0. And what do you get? 4. So what is the x-intercept?
0.
No. When y is 0, x is 4. There we go. What about the y-intercept? Could we get the y-intercept? Just do it. Watch this. So that's the way to do it. You with me? But to find the y-intercept, wouldn't I just make x 0? Wouldn't that just happen like that? Divide by -4, I get. You can do it. You can do it. If you make the x 0, don't I get that? Divide by -4, I get -3. The y-intercept is 0, -3. If you want to see the work, make the x 0, This goes away, yes. Divide by -4, I get -3. So my y-intercept is 0, -3. The biggest mistake I see is somebody will get x is 4, y is -3, and then they plot the point for -3. And then they say to me, what do I do with that shit, Jeff? And I'm like, I don't know. You're supposed to get 2 separate points, right? So if I plot 4, 0, and I plot 0, -3, how do I graph the line? What do I do? How do I plot the line? What do I do? How do I plot the line? Connect. Thank you. Okay. Weehaw. That one big. What's the minimum number of points to graph a line?
2.
2. There you go. So as long as you feel pretty good about those 2, you can always do a third one to check. You just hope it doesn't do like this. Nope, that didn't go right. Who got the number 4? 1 person, 2 people, 3 people. Tell me without any numbers what's true about the slope.
It's negative.
It's got to be negative because this thing's going down. Tell me something about the x-axis units.
It goes to 10.
Goes by 10, so I got to be careful. So if I start here, I go down 3. Down 3 what?
Over inches.
Inches. Over 1, 2, 3, but it's actually
30
10, 20, 30
minutes.
minutes. And if I reduce that, I get 1/10 of an inch per minute. Or 1 inch every 10 minutes is another way to say it. So if I let the candle burn for a minute, it's going to lose 1/10 of an inch. If I let it burn for 10 minutes, it's going to lose an inch. So it takes 100 minutes for this thing to burn away. Can anyone tell me how tall the candle is? 10 inches. You know that because before it started burning, it was 10 inches tall, yes? Okay, look. You guys with me? Before any burning happened, at 0 minutes, it was 10 inches tall. Since it loses an inch every 10 minutes, it takes 100 minutes for it to lose all of itself. You just become a puddle of wax. Okay, how we doing? Alright, I'm gonna let us out. Next time, we'll do the last 2 problems. And then I got my handout for you guys to work on. It's gonna be, we'll see. We'll see if you guys like it or not. If you don't, too bad. Don't remember. Do not remember, there's a quiz tomorrow. The first thing tomorrow is the quiz 3132. Okay.